Teach me about the Great Lakes. Teach me about the Great Lakes. Cha! Welcome back to Teach Me About the Great Lakes, a twice-monthly podcast in which I, a Great Lakes novice, ask people who are smarter and harder working than I am to teach me all about the Great Lakes. My name is Stuart Carlton with Illinois Indiana Sea Grant, and I know a lot about cavernous echo. Layers and layers of echo, like sheet ice on a glacier. But I don't know a lot about the Great Lakes, and that's the point of this here show. And we're joined today by special guest, the lake lover, Megan Gunn. What's up, Megan?
Things are up. It's also very cold. I guess the temperature is not up, so.
No, the temperature, in fact, this is ridiculous. I know that talking about the weather on podcasts is the most cliche, stupid thing, so I won't belabor it, other than to say this. My favorite thing to do is to count the number of days in West Lafayette in which the high is below 30, and it's usually less than 10. And I like to point that out about how we're climate changing our way into like 4 decent seasons. This year, that is not.
No, it's been very cold every day for the last 2 months.
2 months.
Below 30.
Too many.
Too many.
Yeah, we're ready for the spring. Mm-hmm. We got a thing coming up, and I want it to be outside. I don't want it to be inside.
Yeah.
At this bar where the band is playing.
Oh, that'll be nice.
It will, but we played inside right before Christmas.
And it was loud.
To say Christmas. Yeah, it was loud, and it's fine, but outside is... Anyway.
Outside is better.
I wouldn't belabor it. And the reason I'm not going to belabor it is because we got some all-stars here today. So the IJC, who we've talked to before, has just released a really important report on a really important issue, microplastics. In fact, if you go back to literally the first episode, whereby I mean literally the second... No, literally the first episode of Teaching
About Nurdles.
Was about Nurdles. About Nurdles with Sarah Zach. So we've been talking about Teach Me About the Great Lakes for 5... Nope, we've been talking about microplastics for 5 years. But we're not done. But you know why? Because plastics last for freaking ever. So let's just jump right to it. Researcher feature. A feature in which a researcher gonna teach us about the Great Lakes. Today we're lucky to be joined by not one, but 2 researchers and a handful of others. First, I'd like to introduce Dr. Rebecca Rooney. She is in the Department of Biology at the University of Waterloo, which is up in Canada. She's also the Canadian co-chair on the IJC Science Advisory Board's Research Coordination Committee. That's a mouthful, but thank you for being on the show today.
Thanks, Stuart. Hi, Megan.
Hi.
And we're also happy to be joined today by Eden Hadley. Eden is a doctoral candidate in environmental science at the University of Toronto, home of, what was that restaurant? With the Pingai chicken. It doesn't matter, in Toronto. Lovely Toronto. Eden, welcome.
Thank you for having me.
We're also joined by Rachel Wyatt. Rachel Wyatt, who is the International Joint Commission's Great Lakes Regional Office Communications Officer, and she helped to facilitate this dialogue. Rachel, how are things? Where are you anyway?
I am joining you from the sunny tropical location of Guelph, Ontario, where I am currently buried beneath a couple feet or meters of snow, depending on where you're listening from.
Look at that.
I would like meters of snow right now. We just have
snow.
dustings.
Maybe a meter. I don't know if we need a bunch of meters. And we're also speaking, actually, for the first time in my life, but longtime friend of the show, because she contacted me right when we started and gave me just this huge list of topics that we still pull from periodically. Allison Vogelsong-Zanatti, who's a public affairs specialist in the Great Lakes Regional Office of the International Joint Commission. Are you also in Guelph?
Hello, bonjour. I'm in Metro Detroit. Our Great Lakes Regional Office is a binational office in Windsor. So I like to say that I go to South Detroit for work. Okay. South Detroit being Windsor, Ontario, of course.
Oh, nice.
Oh, that's right. You go south. I knew that, too. You go south to get to Windsor.
I didn't know.
You didn't? Did you know that?
I mean, I had kind of paid attention to the map when we were going for the conference last year, but I wasn't driving, so.
Yeah.
I just rode, and wherever we landed is where we landed.
There we go. That's a good way to run your life. Anyway, we're here to talk microplastics, which, as we said earlier, we've been doing since literally day one, but I think it's always worth reviewing. So, Rebecca, give us the big picture. Actually, give us the small picture here. What exactly are microplastics, and why are they a concern in the Great Lakes?
Yeah, so we actually, in our report, proposed a standardized definition for microplastics because different people have defined at least the lower cutoff in size for microplastics different ways. And so we're suggesting microplastics are, polymeric substances, human-made substances that are anywhere from 5 millimeters in size, which would be about the end of a eraser on a pencil, to 1 micron, which is,
it's tiny.
less than a tenth the width of a human hair. So a bit of a range there. And microplastics come from different sources. We have microplastics that are produced. So you talked about nurdles. Nurdles are like an industrial product, right, that are produced as microplastics to be used in manufacturing. But a lot of our microplastics come from other plastics breaking down. And so they break down into smaller and smaller fragments until eventually they're in this microplastic size range. And they come in different shapes and sizes. So we have a lot of microplastics in the Great Lakes are fibers. And a lot of that comes from, our laundry when we wash our synthetic clothes. But there are also tire wear particles that come from driving, wash off our roads. And there's lots of fragments of plastic, which come from all kinds of litter breaking down or construction materials. Foam even used in construction will break down to release microplastics. So lots of different sources, different shapes, different sizes.
I saw that in the report, the tire dust. I thought tires were made out of rubber. I'm not a material scientist. Is rubber plastic? Or, they're not going to the rubber farmers in Acre and tapping the trees. So I guess are tires made of plastic now?
They are, yeah.
Ooh.
And as you get wear on your tire, when you see that groove getting shallow and you've got to replace those tires, well, that plastic went somewhere.
It's got to go, yeah. That is true. So we're probably going to talk about this later, like the removal of microplastics. But is it possible to just scoop it all up and then use them as nurdles to make new products? Or there's so much that we got to use them somehow, right?
Yeah. Why don't I pass that one to Eden?
Yeah, I would say not really, which is the issue with microplastics is remediation is really, really, really difficult given how small these things are. So it's really important to prevent the emission of microplastics to the environment because ultimately a lot of the stuff that gets into the environment is there for the foreseeable future. So remediation, there are people looking into remediation around the world, but on a large scale, I don't know if it's a viable option. So preventing that stuff getting into the environment from the jump is really the name of the game.
Yeah, source reduction.
I want to get into more of that later, but for a second, I want to talk the big picture. So, Rebecca, you mentioned that one of the things that you wanted to do was to standardize the definition. First of all, why is that important, and why hasn't it been done to date? How does one standardize the definition, I guess?
Yeah, so when if you want to standardize a definition, I guess we propose one, and then we ask people to adopt it. And so in our report, we've proposed a definition that comes into alignment, not just, if this definition is kind of adopted across the Great Lakes, but it brings our definition into alignment with work that's going on in California and work that's going on in Chesapeake Bay. So we actually worked quite closely alongside other teams who are addressing microplastic pollution in other jurisdictions to promote not just this sort of binational standardization, but standardization and harmonization of methods across North America.
So when I hear harmonization, I think like Boys to Men. What is the difference between standardization and harmonization?
So harmonization is about bringing everybody's practices into alignment. And I would say standardization is sort of proposing a rigid definition and sticking to that. So we may all be monitoring using different monitoring programs, but if our monitoring is harmonized, then the data are going to be able to be interpreted kind of apples to apples. And if we all adopt a standard monitoring program, then we would all be doing exactly the same thing.
Got it. It's similar to what we do in the fish world with IBIs and indexes of biotic integrity.
I have created indices of biotic integrity, and that's a great example. Yeah, so that would be like a standard that everybody could apply. But if you were harmonizing your monitoring, say, of the fish in a particular wetland or area of the lake with another program that was working in a different region, then at least you'd be able to compare population trends.
Got it. Okay, so important work to standardize. So before there's a danger that people aren't even talking about the same thing, right? And so you have some size class, but microplastics or plastics can get smaller than that, obviously. How do you pick the sizes for? Sorry, nobody cares about this but me. But how do you pick the how do you decide? All right, this is our cutoff. Is it just, hey, here's a nice round number and we got to cut it off somewhere, or is it based on some sort of reality?
Well, you raised a really good point. I'm gonna I don't know. I'm gonna pass this to Eden, but okay. One of the big questions everyone has, right, is how much microplastic is there in the Great Lakes? Mm-hmm. And one of the reasons it's hard to have an answer to that is because of differences in monitoring practice. So, Eden, do you want to talk about that a little bit?
Mm-hmm. Yeah. So, I mean, I don't know the answer to your question of why these upper and lower bounds were chosen as a common way to define microplastics. As Rebecca was talking about, I think it may be connected to methods and the methods that are used to monitor microplastics. And because microplastics are a size-based contaminant, different methods can capture different sizes. So one method that's been commonly used in the Great Lakes is using nets that are towed from boats to capture and isolate microplastics from the water column. And these nets may have different mesh sizes. Yeah. Mesh sizes. Different nets may have different mesh sizes. It's very common to have a net with a mesh size of 300 microns, which means that anything that's smaller than 300 microns is going through your net. So you're actually not capturing that. You're not isolating it in your sample. You're not counting it towards your concentration. But that can differ. And then as a complement to nets, another type of method that's used to sample microplastic is pumps. Now, pumps can go a lot smaller than 300 microns because they don't have that mesh net component to them. And so when you're trying to compare a sample collected with nets to a sample collected with pumps, you're comparing apples to oranges because they've captured different size ranges of microplastics. And we've come to learn that microplastics typically increase in concentration as you look at smaller sizes. So if your sample is collecting smaller sized microplastics, you're probably going to have a higher concentration. So you can't really compare that way. So that's why this size portion of this definition is so important. Because you can't really compare between those two samples, So you can't say this area of the lake has a higher concentration than this area of the lake, which means the species that reside there might be at greater risk because you're capturing different size ranges.
So you've got to get people talking the same language. So you're not talking across each other. That makes a ton of sense. And I guess the reason the concentration increases is because as you break up big bits, they turn into many smaller bits. Like we're recording this on what month is this? February 21st. And right now there's sort of a little bit of alarm, low-grade alarm, but existing alarm about this meteorite that might crash into Earth and blow up an entire city in the year 2038 or something like that. And so one of the things we might do is blow up the meteorite. And if so, then we'll have lots of little meteorites instead of just one big one. But the little ones will hopefully do less damage. Is that why they're more... That's a tortured analogy, but is that why they're more smaller microplastics than larger ones?
I think I would say if you were to take a plate and you shattered it, right? The smaller the fragments, the more the fragments. And so the more we include those small pieces in our measurement of the concentration of microplastics in, a liter of water, the higher the count of microplastics in that liter of water will be. But there's also biological reasons why the size matters as well. So if you're thinking about organisms that are consuming that plastic, like one of the main ways that we understand microplastics to negatively affect aquatic organisms is through them consuming it. And when it gets into their guts, it fills up their stomachs and they eat less because there's just not as much space for them to get food in. So they have sort of a nutritional deficiency from consuming the plastic. And then plastic
getting full, but not getting nourished, I guess.
Exactly. It's like eating a bunch of junk food. You're just eating a bunch of plastic. And then below a certain size fraction, which I think is 53 microns, there's evidence as well that those can pass from the gut into the body of the fish.
It's 83. Do you want to say that again? It's 83, yeah.
Thank you, Eden. Yeah, so below 83 microns, it can pass into the actual tissues of, say, a fish that's consumed a particle, and that we call tissue translocation, and that has additional effects like oxidative stress. It causes inflammation, and so it can harm the animal in a different way than just that nutritional limitation of filling up the guts. So the difference between those two effects is really size-based. So size matters a lot.
Allison, what does the IJC say about size?
Well, what Rebecca and Eden are talking about are included in the IJC Science Advisory Board Research Coordination Committee's report. So that's consistent with the findings. I just wanted to note that, the report and what their research and their study did is looked at the microplastics. So not just that floating in the water, but also in the sediment. So the dirt, right, the muck at the bottom, that's where a lot of organisms live and also, forage for food. And there's significant amounts of microplastics found there. There's not as many studies that we looked at that were measuring the microplastics in that sediment, right, in the mud that squishes between your toes. And then additionally in those organisms, right? So you've seen the pictures of the birds with their stomachs just full of pen caps, right? So we were in this research looking in terms of the aquatic environment at fish, but also at those itty tiny little critters, right? The phytoplankton and the microorganisms as well. And so that's the scale at which they can consume and be affected by microplastics in the water and the sediment, and then also then in these organisms. And that's why the range is from like Rebecca said, the end of a pencil eraser all the way down to what was a third of the size of your hair. That's because it's that wide range of organisms that are consuming it and where it is in the sediment and the water.
As I get older, that third of the size of my hair gets smaller and smaller.
It's the 10th of the size of a hair, but I'll let it go. It's very close.
A tenth of the size. Yeah.
We talk a lot about the prevalence of microplastics. And last time we did sort of a research roundup on this. The take home, this might have been way back in episode 1. The take home was that we know they're everywhere. We're not real sure what they do yet. But you're describing a lot of potential physiological distress on fish and other animals, birds and wildlife. Eden, has there been much research, or can we draw conclusions yet about the negative effects of microplastics? Do we have any science-based conclusions on that? Because my understanding was that it was still early days last time we talked about it.
No, absolutely. There's plenty of studies now published in the literature that show that microplastics can cause harm to lots of different types of species, lots of different types of impact on growth, reproduction, survival, things that happen at lower levels of biological organization, like at the gene expression level. So yes, the evidence exists. I think where we're at now is we don't quite fully understand what about the microplastics is causing these effects. So we know size is important. The physical nature of the particle is important, but there's also the chemical nature of the particle. So the microplastics are, of course, made of polymers, and then they contain all of these different chemical additives. So they have both this physicality and this chemical nature, both which, of course, have the potential to cause harm. We know a lot of the chemicals that are used as chemical additives in plastics are toxic. So I think that's where we're at now, is really trying to narrow in on what exactly about these microplastics is causing this harm, which is an extremely difficult question to answer because microplastics are incredibly diverse in their physical nature. Their size, we already talked about how they can range from 5 millimeters down to 1 micron. They constitute a whole bunch of different shapes. They constitute a whole bunch of different colors. And then on the chemical ends of things, there's many different types of polymers, thousands of different types of chemical additives that are intentionally added to microplastics. And then in the environment, they can pick up and accumulate other environmental contaminants. So it's a very complex question to try to answer what exactly about the microplastic is causing the harm. And in our work with the IJC, we focused and narrowed in on, as Rebecca was describing, the physical elements of harm. So this food dilution or filling the gut, and this tissue translocation or moving from the gut into other tissues. So those are the elements that we focused on. We didn't really start to dive into this chemical side of the issue.
Where does your research fit into all of the microplastic world?
So a lot of my work is really actually focused on this risk assessment framework that considers this size-based impact of harm. So in terms of risk assessment, which was, one of the 3 parts of the work that the IJC work group did, the framework we're adapting and applying to the Great Lakes is very novel. It's, this is really, I think, kind of the cusp of this type of work. So
the cutting edge.
The cutting edge. Yeah, it really is the cutting edge of this type of work. So there isn't a framework like it that considers, the chemical nature of harm for microplastics yet. So a lot of my work is really focused on this physical harm-based risk assessment framework that the IJC has used in their work as part of this work group.
I like that you said yet. I mean, this is a lot that's happened in the last 5 years since we first talked about nurdles and microplastics. So maybe in a couple years?
Oh, absolutely. Yeah, the field is advancing rapidly and we're learning more and more and more every year. I think if you probably would talk to researchers who, have done this since the start of the field, maybe 10 or 20 years ago, they would just be like, wow, yes, we've really, really made big advancements. So no doubt, I think we'll continue to move forward and understand things better and better.
Yeah, awesome. To give a little context, one of the outputs of our IGC Science Advisory Board work group was to help update a database on all the published ecotoxicology papers that have come out. And there are now over 300 papers that are synthesized in this database called Tomex. It's now Tomex 2.0. And that's what Eden's talking about we use to do this risk assessment. So when we say there's a lot of work that's been done, we're talking 300 published studies that we helped integrate into this risk assessment for the Great Lakes.
That's awesome.
And so in your risk assessment, you have thresholds, right? Different thresholds. How does the concentration of microplastics currently compare to those thresholds?
So I personally don't like to focus too hard on the actual values of the thresholds because the beauty of this framework is it's iterative. So as more and more data comes out, maybe that data is more fit for purpose for use in risk assessment. We can add it into the framework. We can bolster what we're building and then rederive these threshold values, and they might be more robust because they're built off better data. So I would say our derivation of thresholds is preliminary because a lot of the data that currently exists isn't fully fit for purpose for use in risk assessment. So I think that's an important point to note is that, this is meant to be iterative. What we have now really offers us maybe a preliminary risk assessment, but there's 2 parts to risk assessment. So there's these thresholds, but you also need monitoring data, so reported concentrations of microplastics in the Great Lakes to actually compare to these thresholds. So I said, there's still room for improvement on the data that underpins the thresholds, and there's also still room for improvement on the monitoring data. So we talked a little about harmonization of methods. A lot of the data that exists for microplastics in the Great Lakes has not been collected using harmonized methods. So it's apples to oranges comparisons. And plus, not all of the lakes have been sampled even close to extensively. So I think on the lower end, maybe it might be Lake Huron, I believe. We only have 12 data points for Lake Huron. So, it's hard to say with any sort of confidence that Lake Huron sits here or here or here on a risk assessment. Things look good, things look bad. Right now it's really preliminary. But what I can say from a preliminary risk assessment, we do see data points in lakes Ontario and Michigan that cross that upper threshold value. The other 3 Great Lakes, Huron, Superior, and Erie, the majority of the data points sit below the lower threshold. So we derive 2 thresholds. The lower threshold is representative of concentrations of microplastics at which 5% of species in a community would be negatively impacted, while the upper threshold is representative of concentrations of microplastics at which 30% of species would be impacted. So again, that HC30 value, we see some samples from Lakes Ontario and Michigan exceed that value, but for that HC5 value, we see Huron, Superior, and Erie all kind of remain below that threshold. But again, preliminary on both ends of the equation.
And we should sort of say, I was going to jump in and say, and we should sort of paint the picture of the framework, which is based on trying to match the state of the Great Lake reporting that's already taking place. So that would assess the condition in the lakes into one of three bins, either good, fair, or poor, depending on whether you're below the low threshold, in between the thresholds, or above the upper threshold.
Yeah. And if I could just jump in, as the public affairs person, I get the emails, oh, I like this report, thank you for this, right? Or people, and some of the feedback we've gotten is, we don't need more studies to tell us microplastics are bad. And I think it's important. There's certainly no studies saying microplastics are good for the environment. Yeah. And I think it's important to clarify that the research question at the heart of the IJC Great Lakes Science Advisory Board's report is not how bad are microplastics. It's to understand the state of the science. Do we have enough information about where microplastics are, how many are in each of the Great Lakes, in order to know and inform our actions and decisions? What can we do to make the situation better and make the Great Lakes more fishable, drinkable, swimmable, right? And so what the report did is it looked at, okay, well, here's all this research we have. And the research is very project-based. It's very one-off. It's not systematic, like Rebecca was saying. And so the conclusions of the report are that we need to have systematic monitoring that's using standards, right? Using standard operating procedures that can be harmonized so that Canadian researchers and U.S. researchers can put the numbers together and say, aha. And what that aha is that's missing that we need from that monitoring is, how bad is it, right? So like Eden was saying, when it comes to the lakes, once we have enough data points, are we exceeding the threshold of 5%? Is it fair? Is it bad, right? And that gives us a picture of the now. And then over time, as we do that regularly, it'll give us a sense of, are things getting better or are things getting worse? So regardless, under the Great Lakes Water Quality Agreement, one of the principles is precaution. We shouldn't let a lack of scientific uncertainty about if microplastics are, how bad are they, prevent us from taking action to prevent the environmental degradation that we know is occurring from, this pollution entering the lakes. So ultimately, we have a framework that we could then implement and monitor and say, okay, let's get a sense of where we're at now, not just from these one-off, studies, but systematically. And then we can know, are things getting better or worse? And then we can also make plans for, how do we reduce plastics from entering the environment in the first place? And then the monitoring data will allow us to say, are our plans effective or not? So this is really a long range strategy that the board is trying to put together and predicate all of this information on. So there's a lot of information out there, but we need even more to be able to act with certainty and make plans that can actually move the needle on microplastics in the Great Lakes.
Yeah, I hear you there, Allison. It reminds me, it's so reductive to say, microplastics are bad. That's not the point of the studies, but, that's a conclusion that comes from them, but it's really a lot more than that. And so I hear a few things in what you're saying that really resonate with broader themes in the show. The first thing is that a lot of academic work is always going to be project-based because that's the incentives, right? You go and you get a grant, you do a project, and then you go and you get another grant because A, that's what you're interested in, B, you're also interested in remaining employed, and so that is the way that it is, and that's just a theme of academia. And then related to that, though, this is where long-term monitoring programs are worth their weight in gold. And those are often government programs, right? And we're in an era right now, very much in particular, where people are questioning the value of government programs, long-term government environmental science programs. And I am not going to get into a discussion of that as a publicly funded person, but I think that it's worth remembering that if that work doesn't get done by government monitoring programs, then it's not going to get done. And
I think one of the recommendations from our report is actually to consider listing microplastics as a contaminant of mutual concern under the Great Lakes Water Quality Agreement, which would require some reporting and monitoring. And also we recommended that it be considered for inclusion as a sub-indicator under the toxic chemicals sub-indicator for the State of the Great Lakes reporting. And that would also kind of feed in well to that, government-run, large-scale, consistent year-to-year long-term monitoring, which we need to be able to assess trends. So, and to Allison's point about, precautionary, I think we should always be precautionary, but because microplastics don't go anywhere, they kind of just break down into smaller and smaller pieces. We need to be extra precautionary because we don't have remediation strategies that have proven really effective. Once the plastics are out in the environment, we've kind of lost our ability to really reel them back in. So if anything, I think, in our literature review, it's really confirmed how much we need to be precautionary when it comes to microplastics.
And what's great about that is, or the other thing I think that is worth remembering is, and what's really nice about this framework that you're developing, and as Eden's point that it's, it's preliminary, but this is a long-term deal. Microplastics, I mean, in all honesty, frankly, at my age, this is more a problem for my kids and grandkids. Like, we're beginning to work there because they're not going away in the next however many years I have left, right? 95 to 120 years.
Yeah, I like
that. But and regardless, there's going to be trade-offs. We're going to be talking about trade-offs. And that's why I think this framework is so important, because it sort of systematizes this idea of trade-offs. As a society, we're going to have to make trade-offs because we're not going to eliminate plastic. We're not going to develop microplastic-free plastics that go into wide use anytime soon. And we're not going to develop removal systems that are perfect anytime soon. And so we're going to be making trade-offs. And the only way to do that is with your eyes open and to do it in a way that's systematic and do it in a way that you're speaking a common language, or as Eden put it, comparing apples to apples, or knowing that one is an apple, one is an orange, and having a fruit-based conversation, I suppose. But so let's talk about these recommendations. Let's go to the trends that you moved us over there. So there's a number of recommendations, and this is an IJC thing, right? Is that they make recommendations. They don't really have the power to do the actions, but they can suggest that other people do it. Is that right? Is that a proper understanding of the IJC's role here?
Allison will correct me if I'm wrong, but I would say that's a pretty good summary. Yeah, we are an objective sort of third voice, and so we can make recommendations to the parties, and we can assess their progress towards their own commitments. But yeah, it's not within our wheelhouse to sort of implement our own recommendations.
Yep.
And I will say our listeners are regular people that can implement different practices to limit the amount of microplastics that are going into the water. And I also selfishly, I'm going to tomorrow, the Chicago River Congress, which is hosted by the Friends of the Chicago River, is hosting an event for people to come learn all kinds of different things that are related to keeping the river clean and keeping Lake Michigan clean. But we're going to be talking about microplastics at our booth. And so outside of telling the kids, like, okay, don't try to limit the amount that you're washing polyester or limit the amount of plastic bottles that you're buying, what other recommendations can we tell regular people that they can do in their everyday to help better this in the future?
Yeah. Eden, do you want to take this about the retrofit on washing machines?
Yeah, that's a really good one. So in our literature review, we looked at the shapes. I mentioned how microplastics have the shape component. We looked at the shapes that are most commonly found in the Great Lakes, and the number one shape across all of the different environmental matrices we looked at. So water, sediment, biota, and on the shoreline. It might have been different for the shoreline, but it was definitely for biota, sediment, and water. The most common shape was microfibers. And microfibers are commonly shed from the clothing that we wear when we wash them. And of course, that washing machine effluent is sent straight to the wastewater treatment plant. And when the wastewater is treated, a lot of the fibers do get pulled out. But because the sheer number of fibers going to the wastewater treatment plant is so large, there's still a significant number that get released in wastewater treatment plant effluent to the Great Lakes. So a lot of washing machines don't contain, a microfiber filter, kind of similar to the lint filters you get in your dryer, but they don't kind of have similar counterparts in washing machines. So folks can actually purchase filters that there's a whole bunch of different brands available on the market. They can purchase filters and install them on their own washing machines at home. So that's a really good way that people in their own house can start to make a difference in their own, emissions of microplastics. Of course, that's, one thing that people can do, but I will mention there are countries around the world that are trying to actually regulate that companies that make washing machines actually start to put in filters at the stage of manufacturing. So I think France was the first country in the world that actually passed regulation. And theirs, I believe, is current as of January 2025. Manufacturers who sell washing machines in France have to have a filter built in, which is, of course, the ultimate goal, right? Isn't that people have to purchase something to put on their washing machine after it's been manufactured, but that they actually built into the manufacturing process. The NDP here in Ontario, I know you guys are down in the US, but one of the political parties here in the province where we live in Ontario has tried to pass a bill 2 times now to do this, but hasn't been successful. So there are things happening kind of in North America as well. They're kind of pushing for this type of regulation, but it's a good opportunity for people to make a difference right now when this kind of manufacturing filter thing doesn't exist yet.
Mm-hmm. And then another one is just common sense, like don't litter and pick up litter. So when you think of a plastic bottle that you see, on the side of the road, when that plastic bottle breaks down into smaller and smaller fragments, it can produce millions of microplastics. And so picking it up when it's still a bottle is a lot more efficient than trying to sift through the sand on your beach and pick out microplastics. Yeah. So preventing litter and controlling losses from landfills, when you put your recycling out on recycling day, making sure that doesn't blow away, those can actually make a big impact as well. And then another thing is just a lot of our microplastics come from industrial sources. So having really good controls on making sure that we're not spilling nurdles or losing microplastic pellets at industrial locations is also important.
Do we have an idea, and I want to get into the official big recommendations too, right? To make sure we get those out there. But we're talking about the individual actions that people can take. Do we have an idea of the relative, how much does individuals, how much do individuals contribute to the microplastic problem compared to big corporations or tires or whatever? So if I'm really careful and I go out and buy a filter or whatever, and everybody does, is that going to make a dent, or is it? It doesn't mean it's not worth doing, but I'm just curious, or is it no, until we get really upstream with the companies, it's not going to make a difference? But every step helps.
For microfibers, washing machines are the biggest source. So if we all put these aftermarket filters on our washing machines, that would make a big dent for sure.
Yeah, I'll add, there's actually been some numbers put on that. So there was a study that was led by a PhD student in my lab a couple of years ago. Her name is Lisa Erdl. And she installed these filters at 10% of the homes in a community north of Toronto called Parry Sound, and then monitored before and after the levels of microfibers they saw at the wastewater treatment plant. And they saw a 10% decrease at the wastewater treatment plant. So 10% of homes in the community led to a 10% decrease of what was actually going to the wastewater treatment plant. And then, of course, that trickles down to what's released into the local aquatic environment. So for washing machine filters, there's actually numbers to show that individual action could make meaningful results. For other types of sources, there's so many types of sources of microplastics. So that question could be hard because you could parse out where individual action may be beneficial versus where you need something, at a higher level. So the answer might be it depends. But for microfibers and washing machine filters, we have numbers to say
so
yes.
There's certain types in where we know it's a big difference.
Yeah. Those would be the low-hanging fruit, I'd say. But I think, from our report, the main recommendations that we're making are, focused on transmitting those recommendations to the parties. So they're recommendations for government. And the first and foremost is just to have regionally coordinated monitoring across the Great Lakes. That's a big gap. that we really need to address. There are some research gaps that we need to address as well. For example, just better understanding the effects of microplastics when it's in the sediment, and having more research done on sediment-based exposures, because so many important biota in the Great Lakes actually live along the bottom of the Great Lakes, not up in the water column. And I think another key is just having more studies on Great Lakes relevant species. A lot of the published studies are done using these kind of classic test organisms, zebrafish and, African toads, which are species that we're not finding in the Great Lakes. They might be analogous to species in the Great Lakes, but it would be great to have more on like some of our native mussels, for example, to have a better ability to refine those thresholds like Eden talked about in the risk assessment. So those are some of the major, I think, research gaps. And then to sort of feed into that, listing microplastics as a chemical of mutual concern and as a toxic subindicator under the State of the Great Lakes reporting would really help kind of consolidate some of that monitoring effort and really get at that region-wide understanding of what are the trends and what is the state of microplastic pollution.
Yeah.
This has all been... Go ahead, Allison.
Yeah, I was just going to say, I think Rebecca makes that good point that, Eden's example was local impact and measuring, but it was monitoring that the data enabled us to know, was the intervention successful? And so without that systematic monitoring, it's difficult to know if every single person in the, if everyone's washing, dishwashing, wrong one. Let me start over.
Laundry.
It's difficult to know if everyone's laundry machine were regulated and mandated and all of a sudden, boom, we all have microplastics. If we're not monitoring and regularly reporting, we won't know that cumulative impact because we won't have a baseline against which we can compare to know if the direction of microplastics are decreasing or increasing based on that. We can't really evaluate the effectiveness of that. And Stuart, to your earlier point, this report's not the first time the IGC has been paying attention to the issue of microplastics, and the commission, capital C commission, right? Not just the Science Advisory Board, but the commission issued some recommendations back in 2017, and they didn't just look at the state of the science. At that time, they did say, hey, we need to monitor this. Right. And that action hadn't been implemented by governments, right? Because these are non-binding. These are just science-based advising recommendations to governments. So in 2017, we made these similar recommendations. And the commission also, recognized that this is a plastic industry source problem. It requires a plastic industry source solution. And so the IGC actually recommended that governments promote life cycle responsibility for producers. There's this, catchphrase of extended producer responsibility. If you make it, it's your job to make sure it doesn't get stuck out in the environment and that it's captured in some way. And so the IGC has promoted through this 2017 report, and then similarly in a big assessment report that we do we do those every 3 years. That was also a recommendation to governments. So it's been several times that the International Joint Commission has said that this requires, regulatory or large scale targeting industry solution. In addition to, I think at this point, there's no such thing as a bad solution to microplastics. We really need collective action, all of the above reduction of microplastics to tackle the scale of the issue.
Well, this has all been fantastic, and you all are doing amazing work. And I wish you luck, Eden, as you continue probably defending your thesis soon and just being done with school. But this is not the reason we brought you all here on Teach Me About the Great Lakes. We brought you on Teach Me About the Great Lakes to ask you 2 questions. Our first question is, if you could choose between a donut for breakfast or a sandwich for lunch, which would it be? And why?
I'm going to hand that one off to someone. They will all jump in at once. So we're going to go around the circle of power once again. And we're going to start off, it looks like Allison. You're going to be first. Allison.
Sandwich for lunch. All the way, baby. Donuts are overrated.
And so if we go to South Detroit and want a delicious sandwich for lunch, where are we going to go?
in South Detroit, Windsor. Ask me in a couple of weeks after I return to the office full time. I don't know. It's still open post-COVID.
Yeah, we've all been there. All right, Rachel. So this is going to be your big contribution, so don't blow it.
Oh my God, so much pressure. I just wanted to add in that, the IJC was created by the Boundary Waters Treaty to act as an independent advisor to the United States and Canada. And part of that function is, we assist Canada and the U.S. through the Great Lakes Water Quality Agreement. So we work cooperatively to help restore, protect, and enhance the water quality of the Great Lakes. And part of that role under the agreement includes providing advice to the governments on different research and science and water quality matters. And that's where sort of our power to provide recommendations to the government comes from. Okay, so as you guys could tell from my big reaction to Allison's statement that donuts are overrated, I would take a donut for breakfast. And I'm sure this is going to be a hot conversation between Allison and I when we're back in the office together.
So where should I go to get a donut then? I want one of these donuts that are so good that it's worth giving up a sandwich for.
I am a bit of a donut connoisseur. I will share that instead of a wedding cake, my husband and I actually had donuts at our wedding. And if you are, traveling around the Great Lakes Basin and you find yourself in Hamilton, Ontario, I recommend that you go check out a little place near Hamilton Harbor called Granddad's Donuts.
Granddad's Donuts.
They sound classic.
They are.
They do.
Was your wedding donut from Granddad's or?
No, my wedding donuts were from a place in Guelph called Lady Glaze. We got custom donuts.
Got you in Waterloo too, Lady Glaze.
Yeah.
Okay, writing this down. We actually, I'm not even joking, have an intern who tracks all of these, and I'm going to release a map someday. But instead, right now, it's just sitting on my hard drive unreleased. But, all right. Eden Hadley. You're Toronto, right? So, are you a donut or a sandwich person?
I'm going Team Rachel. I'm going donut. I'm really into donuts right now. And honestly, I don't care where it comes from. I just like a lemon-filled donut.
Okay.
So, I'll take anywhere as long as it's a lemon curd-filled donut with, icing sugar on the outside.
Yeah, gotta have that.
It's all sugar.
All sugar. I know the reason why. Here's why. It's because for lunch every day you go to Queen Mother, is the restaurant in Toronto, with the pingai chicken that is so unbelievably good. I live in West Lafayette now, so we were at Agler a couple years ago. West Lafayette doesn't have a single good restaurant. It just doesn't. And so we were in Toronto, and, there's an exchange rate that was quite favorable at that point. And so, man, I was going to every decent restaurant in that city. And
there were a lot.
There were a lot, but the pingai chicken was my favorite.
There are a lot of unbelievable restaurants in Toronto. It's problematic living here as a grad student. That's a day-to-day challenge.
Yeah, but the money you save on beer, because the beer is terrible, you can spend on restaurants. Anyway.
Oh my gosh, throwing down the gauntlet, Stuart.
Opinions. It's too bad Carolyn couldn't make it. She would come to Toronto or Canada's defense, but alas, she's not here. All right, Rebecca.
Yeah.
University of Waterloo. Am I going to get a donut or a sandwich?
I think if you come to Waterloo, you're going to want to go up to the St. Jacobs Farmers Market and get one of their world famous apple fritters. And
we have had debates about this.
This is it is a regional delicacy. So we do have Lady Glaze, and I love a donut with a whole butter tart, and it's basically like a Caesar, but a donut. But you can't get better than an apple fritter from St. Jacobs.
This has been unbelievable. We've had 3 out of 4. Sandwich, overall team sandwich is the winner, over the 110 episodes or whatever it's been.
Because that is the correct answer, Stu.
All right. The other thing we'd like to ask, so the purpose of the show, other than to get to screw around with my friends for an hour every couple of weeks, is to try to help people appreciate the Great Lakes as a scientific, ecological, and cultural, just special place, which is what it is, right? And I didn't appreciate that until I moved here. But it really, really is. And so one way that we like to do that is we like to ask about special places in the Great Lakes. So we're going to take this briefly. Eden, is there a place that you find to be really special that you'd like to share?
Yeah, I grew up in Kingston, Ontario. So Kingston, Ontario sits at, I guess, kind of the end of the Great Lakes. It sits where Lake Ontario meets the St. Lawrence River, and also where Lake Ontario meets the Rideau Canal that takes you up to our nation's capital, Ottawa. So it's kind of cool, you know, it's this meeting place of all these different water bodies. And so that's definitely my special place. I spent a lot of time swimming in the river, swimming in the lake when I grew up. So that's my favorite part of the Great Lakes.
That's wonderful. Rachel, how about you? Is there a special place in the Great Lakes to you?
Yes. So in the Lake Huron watershed, there is a tiny, I don't even know if it technically is considered a village. It's called Magnetawan, Ontario. And my family has cottages on a lake there. And I'm a member of the third generation going up to that lake, like every summer. And then there are 2 other generations coming up behind me. So that's a very special spot in the basin for myself and the Wyatt family at large.
Dang, we should have ended with that. Oh, well, too late. Allison, how about you?
All right, I won't gatekeep, but I'll just ask anyone visiting this place not to litter it with plastic pollution or other pollution. It is Sturgeon Bay Beach, just south of Wilderness State Park in Michigan on Lake Michigan.
There it is, Sturgeon Bay Beach. And we're going to put at least all these in our show notes, except for your private cottages, of course, Rachel, which you can find. Just look in your podcast player now, or this is probably episode 108. 109, I don't know, just go to the website. It's hard to keep them all straight at this point. In the hammer position, Rebecca Rooney, what is a special place in the Great Lakes?
I'm going to have to say the Long Point World Biosphere Reserve on the North Shore of Lake Erie, where I do a lot of research in my day job, which is as a wetland ecologist. And so there, it's if you take the Long Point on its own, it's about 70% of the remaining intact coastal wetland on the Canadian side of Lake Erie. So it's a really special place with Canada's oldest bird observatory and with just an enormous diversity of species at risk. So I love to go out there with my students and look at the plant community, look at the bugs, look at the birds, and collect some data for science.
Well, Allison Vogelsong-Zanotti, the public affairs specialist at the Great Lakes Regional Office of the International Joint Commission. Rachel Wyatt, who is the International Joint Commission Great Lake Regional Office Communications Officer. Eden Hadley, PhD candidate, soon to be Dr. Eden Hadley, hopefully, at the University of Toronto, and Dr. Rebecca Rooney at the University of Waterloo, and the Canadian co-chair on the IAJC Science Advisory Board's Research Coordination Committee. Thank you so much, all of you, for the great work that you do and for coming on the show to teach us all about the Great Lakes.
Thank you for teaching people about the Great Lakes. We need more people to understand and support them.
You're so kind.
Thank you.
All right. Fascinating conversation. Interesting people. Important work.
Fantastic work.
Yeah.
About a very tiny, tiny subject.
It's a tiny problem.
It is a tiny problem.
It's not actually a tiny problem. A tiny problem. Oh, yeah. A tiny problem with huge implications.
Which huge, massive. Just even thinking about how they were saying like 30% of the species, and I'm guessing it's more than just fish species, but species in Lake Michigan are impacted by microplastics. It's sad. And
it is sad because you see, it's a thing, right?
Mm-hmm.
Because it's like, well, you feel like our human problem should be just with humans, right? And it's like when you see there is something to that, seeing all the animals suffer as well.
Things that we've done.
Things that we've done. Wow.
Yeah. It's gross.
Teach Me About the Great Lakes is brought to you by the fine people at Illinois, Indiana Sea Grant. We encourage you to check out the cool stuff we do at iiseagrant.org and at ILI and Sea Grant on Facebook. Look for us on Blue Sky and other social media.
Our senior producer is Carolyn Foley, and Teach Me About the Great Lakes is produced by me, Megan Lake Lover Gunn, and Renee Miles. Ethan Chitty is our associate producer and fixer, and our super fun podcast artwork is by Joel Davenport. Riley Ramsey is taking care of business, and the show is edited by Sandra Sabovida.
If you have a question or comment about the show, send us an email, teachmeaboutthegreatlakes@gmail.com. That's what I heard from IJC. They sent us an email on the email hotline. Speaking of hotlines, leave us a message. 765-496-IISG. That's 4474-4474. Thanks for listening, and keep grading those lakes.